Let V with a vector space over R consisting of polynomials of degree less than or equal to 3. Let a linear transformation or operator T defined from V to V means vector space to vector space and image of domain elements is going by this relation ft plus 1 means 1 exceed in the parameter, and D is another map or operator send domain elements to its derivative. Then T is a polynomial in D. What its meaning? T is polynomial in D. As we say polynomial in X, it means that Cn x raised to the power n, Cn minus 1 x raised to the power n minus 1 and so on plus C naught. This is polynomial in X. If T is a polynomial in D, then T can be written as Cn d raised to the power n plus Cn minus 1 d raised to the power n minus 1. These are suffix or superscript as how many times we differentiate or we apply operator D. This is how many times operator D used. Operator D used. Please do not understand this as a exponent. Its simple meaning operator D apply how many times means D square means D of DF. This is the meaning. D of DF. D square. And so on up to C naught. This is the structure of T in terms of D. But I am going to solve this problem by matrix representation. You can solve by this because we know the operator D and T, so we can write operator T in matrix representation as well as matrix operator D in matrix notation. This is basis 1 x square x cube, basis 4 p3 r means polynomial of degree at most 3. Degree at most 3. This is notation and this is standard basis. So T send image of f as ft plus 1 and D send image of f as f prime t. This T is parameter or variable. So represent T with the standard basis beta and represent D in matrix notation with respect to same basis because T and D both are defined over same vector space means domain and codomain. So there is no need to consider another basis. This basis will work for domain and codomain both. So these are basis element 1 x x square and x cube. This is basis elements and this is the column of basis elements image means T of element. If this is a basis element, then you can consider this as ft. One by one we will consider ft or in terms of x. You can write So one by one we will consider these element. So T send this image as in parameter exceed 1 means same, exceed 1 means t plus 1, this one will be t plus 1 whole square, and this one will be t plus 1 cube. We can write this one as t square plus 1 plus 2 times t, and this one can be written as t cube plus 1 3 t square plus 3t, and this is the column for d means map D or operator D, and this is basis elements image. So D send elements to its derivative. So derivative of 1 is 0, derivative of t is 1, derivative of t square is 2t, and derivative of t cube is 3t square. From this one, matrix representation will be right image in linear combination of basis element like 1 dot 1 plus 0 times x plus 0 times x square plus 0 times x cube. You can write this one as 0 times 1 time 1 plus 1 time t, because this is parameter t, so write in terms of t, 1 time t plus 0 time t square plus 0 times t cube, and similar here. So coefficients of these linear combination become columns. So first column will be 1 0 0 0, second column will be 1 1 0 0, third column will be 1 2 1 0, and this one will be 1 3 3 1. This is matrix representation for t. So t beta we can write, and this is matrix representation of D with respect to same basis 0 0 0 0 1 0 0 0 0 2 0 0, and this is 0 0 3 0. We have matrix representation. Now asked about T can be written as T can be written as in terms of D. In terms of D, it means all columns of T, means all columns of T can be written as in terms of, can be written as in terms of linear combination of columns of d beta. D beta means matrix representation of D. See here, this is first column, this is linear combination of this one directly or same. This column can be written as this one or this one. We will use these two column. How? This is C2 means these are columns of operator D representation. C2 minus half or 1 by 2 C3. Now this column can be written as this one, and this one. How? C2 plus C3 and last entry is 1. So 1 upon 3 C4. And this column can be written as C2 plus 331, 3 by 2 C3 plus C4 plus E4. E4 means 0001. We can add extra column as this is a basis element, so we can add extra column. It doesn't affect the linear combination. So we can write all columns of T with the help of columns of D. So T is a polynomial in D. This is true statement.